What if I told you that one of the biggest recent upgrades to AI didn't come from some massive, complex new system, but from a really tiny, almost elegant little tweak? Well, it turns out that's exactly what's happened. Today, we're going to break down how a simple gate is making AI models way smarter, a whole lot more stable, and just flat out more powerful.
Okay, so here's how we're going to tackle this. First, we'll get into the absolute core of how AI understands us. Then we'll look at a major glitch that pops up when these models get really big. After that, we'll unveil the brilliant, simple fix. And of course, we got to see the proof, the data, before we wrap up with what this means for the AI you and I use every day. All right, let's kick things off with Section 1. To really get why this new discovery is such a big deal, we have to pull back the curtain on how AIs like ChatGPT actually think. And it all boils down to this one crucial idea: attention. So, at the heart of it all is a process called softmax attention. Now, don't let the name scare you. All it really does is let the AI scan a sentence and give each word an important score. It's how it knows that in "the cat sat on the mat," the word "sat" is the key that connects the cat and the mat. It's the secret sauce for understanding context.
This is honestly the perfect way to picture it. The attention mechanism is basically the AI's digital highlighter. It zips through text, flagging the bits that are absolutely essential for it to understand what's going on and give a good answer. Simple enough, right? But what happens when that highlighter starts to malfunction?
And that brings us right to our next section. Because as these AI models grew to just astronomical sizes, researchers started spotting this weird glitch in the system, a kind of bug that was causing some really serious problems.
Yeah, exactly. That's the million-dollar question. For a while, the highlighter worked great, but in these new, massive models, it started to go haywire. Sometimes it would highlight everything, and other times it would get totally fixated on the wrong things. So, the first problem they found is this thing called massive activation. Imagine taking that highlighter and instead of picking out key phrases, you just color in the entire page. That's what was happening. Everything seemed equally important to the AI, which, as you can guess, just created a ton of noise and confusion. The second problem, the attention sink, is a little sneakier. This is where the AI's focus gets completely stuck on something totally useless, like the very first word in a super long document, or even just a comma. It's called a sink because all the model's focus gets sucked into this one pointless spot, distracting it from what the text actually means.
So you've got this broken highlighter causing all kinds of chaos. How do you fix it? Well, let's jump into Section 3 because this paper introduces a solution that is just so surprisingly simple and powerful.
Okay, that quote sounds super technical, but let's break it down. All it's saying is that the researchers found that by adding one tiny extra step, this sigmoid gate, right after the normal attention process, they could fix both problems and give the model a major performance boost. It's a tiny change with a huge payoff.
So here's what's happening under the hood. It's pretty straightforward. The model does its thing, calculates attention like it always does. But then, before it moves on, this new gate steps in. You can think of it like a bouncer at a club, doing a quick quality check on the attention scores before letting them through. I love this analogy because it's spot on. This gate acts like a super sophisticated volume knob. It lets the model crank up the signal on the words that actually matter, while turning the volume way down, or even completely muting, all the useless noise. And just like that, you've solved both massive activation and those pesky attention sinks.
So what's the magic here? Why does this work so well? Well, the paper says it's for two main reasons. First, it adds something called non-linearity. Basically, this just helps the model think in more complex and subtle ways. And second, it creates sparsity. All this means is it forces the model to be more decisive, to actually ignore the junk and focus only on the few things that really matter.
This all sounds fantastic in theory, right? But the big question is always, does it actually work when you put it to the test? Well, let's get into Section 4, because these researchers really put this idea through its paces.
Yeah, they didn't just try this on a laptop with one little model. They ran tests on over 30 different models, and they trained them on a dataset with, get this, 3.5 times trillion tokens. I mean, that is a staggering amount of data. This is how you prove your idea is the real deal.
And the results? They were crystal clear. It was a win across the board. Performance was consistently better. The whole training process was smoother, more stable. And here's the kicker. The bigger the model got, the bigger the benefits became. And of course, it directly stomped out the two big problems we've been talking about.
Okay, so let's bring it all home in our final section.
Why should you care about some little technical gate? Well, because this tiny change is already making the AI tools we interact with every single day significantly better. You gotta love a research paper that includes a "too long didn't read." It basically says it all right there. This simple gate is an all-around upgrade. It makes things perform better, scale better, and it fixes those huge headaches that developers were running into.
And here's maybe the coolest part. This isn't some theory for the future. This exact tech is already being used in the wild, in models like the Qwen 3 series. So what that means for us is we're getting AI assistants that are more reliable, that don't lose the plot when we give them a giant document to read. It's a stronger foundation for whatever comes next.
And that really leaves us with a pretty fascinating thought to end on. In a field that is so often about just building bigger and bigger things, this paper is a fantastic reminder that sometimes the most powerful breakthroughs are actually the most simple and elegant ones. It really makes you wonder, what other small, brilliant ideas are just waiting to be discovered? Thanks for joining me.